Hey guys, today we're going to be taking a look at writing explicit and recursive formulas for arithmetic sequences. Now, an arithmetic sequence is simply a sequence that has a constant difference. In other words, it's increasing or decreasing at the same rate. So you can kind of think of that in terms of a slope or rate of change or a linear function. So an explicit formula, remember, is written in terms of the variable n. So it might look something like this. A sub n is equal to our first term, a sub 1, plus the constant difference times n minus 1, where a sub 1 is my first term, n is my independent variable or the term number, d is the constant difference between those terms. So these are the three things I really kind of need to know in order to write an explicit formula for an arithmetic sequence. The next type is recursive formula. If you remember that, it's given with a set of statements. It typically gives you the first term, such as a sub 1, and then it writes a sub n, or any term can be found by taking the previous term and adding or subtracting the constant difference to that. So again, this is in recursive formula for an arithmetic sequence, and typically we say that's for n greater than or equal to 2 because we already have been given that first term. All right, and again, we need to know first term, a sub n minus 1 is our variable, and d is our constant difference. Let's take a look at a few examples for today. All right, in our first example, we are asked to write an explicit formula for the arithmetic sequence 6, 10, 14, 18, 22. Well, keep in mind we need to know our first term. In this case, it's 6. We also need to know our constant difference. We see that each one of these terms is increasing by a positive 4, so that is our d. And now we can write our explicit formula. It simply follows a sub n is equal to our first term plus our constant difference times n minus 1. Now, if we want to, we can simplify this by distributing our 4 inside of parentheses here. We'll have 6 plus 4, n minus 4, and now we can combine like terms. So in the end, we could say our explicit formula would be a sub n is equal to, say it's equal to 2 plus 4n. Okay, now we're asked to compute the 25th term. Remember, 25 here is going to be substituted into our explicit formula for the value of n. So we'll substitute a sub n is equal to 6 plus 4 times 25 minus 1 in this equation up here. And we will end up with 6 plus 4 times 24. And that gives us 6 plus 96, which is 102. So our 25th term there is 102. Okay, our next example here gives us another arithmetic sequence. You can tell here what the constant difference is as we jump terms from one term to the next. You know that you need your first term and that constant difference. You're going to be asked to compute your 25th term. It's just like the previous problem. See if you can do this one on your own. Okay, we're back for example number 3. It says an electronic bulletin board charges $2 for each word of a classified ad plus an additional $14 service charge. We want to write a recursive formula for this arithmetic sequence that represents the ads that contain n words. So keep in mind your recursive formula usually starts off with the first term. A sub 1 in this case is going to be the value of 16. That's where n, the number of words, is 1. It's $2 plus the $14 service charge. So 16 is our total cost for one word. And then a sub n, any term after that, would be the previous term, a sub n minus 1, plus an additional $2. That's our constant change for each additional word. And again, this is for where n is greater than or equal to 2. Now we want to graph this sequence. So along our x-axis, we have n, our term numbers, or in this case, our number of words. Along the y-axis, we have our charge, and that's represented by a sub n. Okay, now that we have our axes labeled here, we're going to go ahead and plot our first term with one word we know is going to be $16. After that, we have a slope or a constant increase of 2. So our points should increase as such. And there's the graph. Remember, this is going to be discrete. We're not going to be charging any in-between values here. We either have whole number words, and therefore our prices will increase by $2 each time. Alright, now let's take a look at example 4. We have a wading pool. It's filled to a depth of 36 inches and drains at a rate of 33 inches per hour. We now want to write an explicit formula for this arithmetic sequence that gives the depth of water after n hours. So let's consider our first term here. First term would be 1 hour. So after 1 hour, it should have a height of 33 inches. 2 hours would then be 30, 27, 24, 21, and you get the idea. Our constant rate of change here is 3, a negative 3. So our first term now is 33. Our constant rate of change here is negative 3, and we can now write our explicit formula. Our explicit formula will say a sub n is equal to our first term 33 plus a negative 3 times n minus 1. Now again, I can go back here, I can get rid of this plus. In fact, I'll do that, just erase that out of there. And I have my explicit formula, which is 33 minus 3 times n minus 1. Now I can simplify this again by distributing that negative 3 in. So I'll have 33 minus 3n plus 3. If I add that 3 to the 33, my explicit formula now looks like this: 36 minus 3n. Okay, we want to know the depth of the water after 6 hours. 6 is going to take on the value of n. So we will substitute 6 in for that n, and we get 36 minus 3 times 6, and that's going to give us a value of 36 minus 18, which results in 18 inches. You should see that reflected in our sequence up here. We have our first 5 terms. If we subtract one more value of negative 3, that constant rate of change, we should end up back at 18, and this will be our 6th hour. Okay, in our last problem for today, we want to put the sequence negative 7, negative 4, negative 1, 2, 5 into both a recursive and an explicit formula. So let's start off with our recursive formula. Our first term we'll call a sub 1, and that's equal to negative 7. Any term after that then can be generated by taking that previous term, a sub n minus 1, and it looks like we are adding 3 each time. So we'll say plus 3, and this is where n is greater than or equal to 2. Next, let's find our explicit formula. Our explicit formula can be written as a sub n is equal to that first term plus the constant difference, which in this case was 3, times n minus 1. Again, we can simplify by distributing that 3 inside. So we have negative 7 plus 3n minus 3. And now combine our like terms. Our explicit formula will be a sub n is equal to negative 10 plus 3n.